guys, welcome to this week's advanced concept presentation. This experiment for the week is going to be called elephant toothpaste because we are going to make a reaction that resembles some toothpaste really just foaming out of a container. But for this experiment, we're going to be using hydrogen peroxide, which is H2O2, some dish soap I have here, some yeast, and some food coloring. So I'm going to be following the steps in the procedure that was shown in the video. I'm going to pour some hydrogen peroxide, just a little bit. Okay. Next, we're going to add some dish soap. Next, we're going to add a few drops of food coloring. I also happen to have the same color of food coloring as I do with my dish soap. Okay, I'm just going to add some few drops. Okay, as you can see. Okay, so up to this part, what I have in the cup, it's quite green. So the next step, we're going to have a cup of yeast, and we're going to add some hot water. I already poured the yeast into it and the hot water, so it's sort of like a little paste. It doesn't look like there's enough hot water in here, so I'm just going to add a little bit more. I added some more hot water, and we're just going to mix it together, the contents together, just mix it around a little bit. It's still very pasty, but so I'm just gonna add a final addition of water. Now I think we should be good. I'm gonna give that one final mix. It's my first time doing this, so we're just gonna observe what happens. So once you have this set up in the cup, we're going to pour it into this cup that we had our hydrogen peroxide, the dish soap, and the food color. Pretty cool. Now I think we should be good. I'm gonna give that one final mix. It's my first time doing this, so we're just gonna observe what happens. So once you have this set up in the cup, we're gonna pour it into this cup that we had our hydrogen peroxide, the dish soap, and the food color. Pretty cool. If you guys take a closer look, I made a mess on my kitchen table, but as we saw happen in live time, once we poured the warm water of the yeast into the cup, the foam started to appear and really just like fill up the entire cup and overflow. Yeah, it's a very visual, it's a very cool visual effect. We see that it does smell. I smell the yeast right now. Observations, obviously it's green. I know the green food coloring was really used for the visual effects, but everything just seems very foamy, very voluminous, and yeah, that's pretty much the procedure for this experiment, and I'm very tempted to touch it, but I don't want to get any of that on my fingers. But what makes the foam appear? So when the hydrogen peroxide comes into contact with the yeast that with the warm water, it really starts to uh, undergo a decomposition reaction, breaking down the water and the oxygen. And as we know, oxygen is a gas, so it wants to escape the liquid. But the dish soap that we had in the cup, or in this cup in the reaction, it traps these gas bubbles, and as a result of that, this whole foam really takes effect. And that was this whole foam that we saw was really the main show of this experiment. But for the final summary, yeast contains an enzyme called catalase that breaks down hydrogen peroxide into oxygen gas and water. And this is done by separating oxygen from hydrogen peroxide, as we know, is H2O2. So it gets decomposed into H2O and O2. And with water and oxygen produced, the oxygen gas gets trapped into the dish soap. And when the gas is trapped in the dish soap, the foam appears, and hence the elephant toothpaste experiment. And I did end up touching the foam because, I was curious, and as you can see, my finger turned green, as if I touched the food coloring itself. So finally, something important to note is that this is an exothermic reaction, which is really we've been studying a lot about energy and enthalpy, entropy, and in relation to this experiment, exothermic reaction releases heat as it occurs, which also means that the Q, or delta H, or basically delta enthalpy, which represents the change in enthalpy, a measurement of energy, it's going to be negative because it is releasing energy. The system is releasing energy, so it's losing energy to the system, to the surrounding. So hence the surrounding, or in this case the bottle, or things that was just the thing that was around the system, it becomes warm, and that's the transfer of energy and heat. But yeah, that concludes the elephant toothpaste experiment. I practiced this actually a quick first run off the video, and I actually did fail. I know I initially said that I did it. This is my first time, but I actually practiced it a little bit, and that first time was a fail. So this time, I guess I had the proportions right. I think that I added too much water the other time, and I didn't really get much of the foam, or too less of an ingredient. I'm not too sure, but something with this video was that there weren't really precise measurements or delineation of how much of each ingredient to use. So for future reference, we can be more precise for consistency for any scientific experiment, but to improve its accuracy and data. But other than that, we were able to see the visual effects of the foam. We were able to really be delighted with some elephant toothpaste, and from it learn some scientific concepts. So yeah, thanks for watching.